Welcome back to the lesson of learning chi-square test. In the last video, we introduced chi-square goodness of fit test. So the basic summary for that will be looking to see if your distribution matches the claimed distribution, and there's a hint for you if the question states only one population, one sample, or one variable. But there's two other tests for chi-square, and in this video we're going to focus on these two: the chi-square test of homogeneity and chi-square test of independence. First, what is the test of homogeneity? It's looking to see if the distribution is the same for two populations. Pay close attention to the two populations here. The hint will be two populations, two samples, or one variable in the question. For chi-square test of independence, we want to pay attention to see if two variables have a relationship or association. So in here, we're gonna looking at two variables. A hint for that will be one population, one sample, and two variables for the question. So a lot of people will get confused by homogeneity and independence. Just remember that homogeneity is you have two samples in front of you, and you want to compare them. You want to see what's the similarity of those two. In the other hand, the test of independence is you only have one sample, but there's two variables on this sample, and you want to find the relationship of these two. So be sure to differentiate those, and we will practice. And I hope by the end of this video, it won't be a problem. So first, let's just do a quick review. All three chi-square tests note only test, so chi-square don't have interval. The conditions have to be met, and there are three conditions. First one is data are counts, which means the data you're examining cannot be continuous. It can only be categorical variables. Second condition will be this is a simple random sample. Third condition is expected counts are at least 5 or at least 80% or greater than 5. The test statistic formula we're using is chi-square equal to the summation notation of observed minus expected quantity squared over expected. This will go into step 3. And those condition checking will go into step 2. We're using the table to help us find the chi-squared variable with different degrees of freedom. So instead of using a normal curve to represent chi-squared, we're using a skewed curve. Table entry for p is the point chi-squared with probability p lying above it. So p will always be the right side of chi-squared. This will be the probability. And let's moving on. So chi-square test of homogeneity. Let's learn this by looking at an example. The table below shows the scores of randomly selected students from 2023 to 2025 on the AP Statistics exam over the years. Has the distribution of scores changed over the years? That's what we're looking for. So there's 5 scales and 3 years. First of all, is this a homogeneity? And how do we know it? Well, if we go back to the rules for homogeneity, the question will give us two populations, two samples, and one variable. So, it's not specifically have to be two populations or two samples. In here, it just means more than one. So it can be 3, 4, or 5. But it just have multiple populations or samples. So going back to this example, we have 3 years. So we have 3 samples that we're examining. And there's 5 scores. So the scores is only one variable. We want to see if the distributions of scores changed over the years. So that's only the variable that we're trying to find. So that matches the conditions for homogeneity. And that's good. So we can continue to our steps. We still have 4 steps, just like all of the tests, t-test, z-test we've been doing so far. The first step is stating the null hypothesis and alternative hypothesis. For the chi-square test, these two hypotheses will always be super easy to say because only thing you're going to say is one is the same and one is different. So in this question, it will be the distribution of scores is the same across the 3 years, while the alternative hypothesis will be saying the distribution of scores is different across the years. So we complete step 1. Moving on to step 2. First, as always, we have to state the name of the procedure, what we're doing in here. We're doing a chi-square test of homogeneity. And let's check the conditions. First of all, are the data counts? In other words, are the data categorical? It is. You cannot score 4.5 on your AP test. You can only score 4 or 5, or 3, 2, 1. Therefore, data are counts. There's no intermediate value. Are those 3 samples all simple random samples? It is. Last condition will be checking if the expected value are greater than 5. But be careful right here. Since we have 3 populations, we have to check if all of them are greater than 5. What if one of them is not? We have to draw the conclusion when we are writing our statements. We have to mention that possible source of error. So pause for a second to enter all of those data into your calculator. I'm doing that in here on my calculator too. Or you don't have to pause if, you're typing the same speed as me, but I think I'll try to do as fast as I could. So go into list 1, 2, and 3 and enter all of the data in. After you've done it, you are going to your calculator and go into the matrix, and you're gonna find the values of those, and you will find each expected value. And I'm not listing all of the values in, but on the test you're gonna write them all. So we have a 5 times 3 matrix. According to all of the data that shows on our calculator, the expected values for all 3 samples are greater than 5. Therefore, after checking all of these conditions, we can say the chi-square model applies. Moving on to step 3. The degrees of freedom is column minus 1 times row minus 1. Therefore, in this case, we have 5 rows and 3 columns. We're going to use 5 minus 1 times 3 minus 1, and we get 4 times 2, which gives us 8. On our drawing, we're going to first draw the the null hypothesis in the middle. So this will be degrees of freedom minus, this will be 8 minus 1. 8 in this case is our degrees of freedom. And your highest point, or the peak of your curve, will be degrees of freedom minus 1. Therefore, it will be 7. And it will be good for you to label 0 right here. Let the AP reader know that there's a 0 on the far left of the curve. And you're going to shade the region to the left, to the right of 18.11. And we're gonna moving on to some calculations. The percent of 5s will be 76 over 421. 421 will be the total numbers adding together to get our number, which is 421. And how do you get 76? We are going to the row that have 5 on it and add those 3 numbers together. We get 76. 76 over 421 gives us 0.1805. Therefore, the number of people in 2023 that should get 5s will be 127, which is the total number of people who took the exam times the percentage of people who scored 5 over the years. That's our expected value or expected percent of people who are getting 5 in 2023. But the general formula will be row total times column total over overall total. The chi-square in this case will be the summation notation of observed minus expected quantity squared over expected, which gives us 18.11. The p-value will be 0.0204. Moving on to step 4. This is where we need to draw a conclusion. So in this case, I picked a alpha level. I would say most of the questions will give you the alpha level, but if it doesn't specifically say, you will just go with 0.05. But since we're doing a class notes, it doesn't have to be that specific. We just pick a 0.01 as our alpha level. At alpha equal to 0.01, p equal to 0.0204, which is greater than alpha. So we fail to reject null hypothesis, meaning the AP scores are the same across the 3 years. So remember, our null hypothesis is saying that the distribution of scores is the same across the 3 years. And since p is greater than alpha, we don't have enough evidence to reject null hypothesis. Therefore, our statements will be aligned with null hypothesis. So that's how you do the 4 steps, like completely for chi-square test for homogeneity. I hope it makes sense. Let's moving on. So let's summarize a little bit for the 4 steps that we just did. The first step is hypothesis in words. In the previous tests we've been doing, like t-test and z-test, we always, like most of the cases, we just draw a inequality. But things are changed right now. For the null hypothesis, the distribution is the same for the different populations. For the alternative hypothesis, the distribution is not the same. And we're going to put into context. Second step is name and conditions. The expected value will be the row total times column total over overall total. Third step is picture, chi-square, degrees of freedom, and p-value. So you can see a lot of information are grouped together in step 3. So make sure you show every step clearly. To get chi-square, you're going to use the formula, which is here. And to get degrees of freedom, this is what we've been using. And fourth step is draw the conclusion. So let's do another example for chi-square test for independence. A gym manager is looking to decide what music should be played over the newly installed sound system. She is curious if there is a relationship between music preference and the activity that gym members are performing. She obtained the following data. So in the columns right here, you can see those are different music types. And in the rows right here, you can see those are the different physical performance. So first of all, let's find our degrees of freedom. Using the formula, column minus 1 times row minus 1 gives us 3 times 3, which is 4. No, 3 times 3 is the matrix. So sorry for that mistake. Degrees of freedom will be 4, since it is the categories minus 1. So because we have 3 categories for each, we're going to use that minus 1, which gives us 4. Is there evidence that suggests that there is a relationship between activity and music performance at this gym? Use alpha equal to 0.05. So first of all, if I didn't give you any hint for either independence, homogeneity, or goodness of fit, how will you see this question? What types of method will you use? Stop for a second to think. So we know for the homogeneity, it is when we have 2 samples or 2 populations, but we only have 1 variable. But for the independence, if we want to go back and review our notes, is when we have 1 population, 1 sample, but 2 variables. So let's take a look at this question. Do we have 1 sample? We have. The sample will be the people who went to the gym and got data record for their physical performing, which means basically the people who are doing this experiment. But we have two variables because we want to find, is the music preference and the activity that gym members are performing related to each other? In other words, are they associated with each other, or they have in relationship? That's what we want to investigate. So we have one sample, one population that we're putting experiment on, but we have two variables that we try to find a relationship between those two. So be sure to know the difference. Is there evidence that suggests that there is a relationship between activity and music performance at this gym? Preference, sorry. So that's another hint. If the question shows relationship between two variables, 90% likelihood that this will be an independence chi-square test. So, same as always, do the 4-step. First is stating no and alternative hypothesis. Our null hypothesis will be there is no relationship between music preference and activity, while our alternative hypothesis is there is relationship between music preference and activity. Naming the procedure, we're doing a chi-square test of independence. So just let you review all the steps again, but I know we've been doing it a lot of times. Just if you want to take a glimpse at it before we jump right in, please do. But for right now, I'm just going to skip it. So, actually, let me try to find my another notes. Since this question, we're not showing the whole picture, so that's not good. Sometimes my notes will automatically delete everything if I didn't save it correctly or immediately. I hope this version have everything. Well, seems not. Okay, so anyway, the procedures are almost exactly the same. So if you follow those steps, you will find yourself in a good shape. But if I just want to talk it over through it, it will be after we naming the procedure, we're going to check the conditions, which is, are the data categorical? In other words, are the data counts? Second step will be, are those simple random samples? Since we only have one sample for independence, we don't have to check anything else. We don't have to make sure, okay, there's 3 simple random samples or 2. Since we only have 1, we don't have to care about those things. And last is checking the expected value is greater than 5, or at least 80% of it are greater than 5. So, for example, like remember the example we've been doing right here, the matrix stuff. If one of the column didn't show all of the values greater than 5, it's fine, because as long as most of the data are greater than 5, if we only have 1 or 2 values not greater than 5, it's okay. We only want to make sure majority of them are greater than 5, which is why that we say 80% of them greater than 5, not 100%. So after we checking all of the conditions, we're gonna calculate the exact expected value, which use row total times column total over overall total. Third step is doing the picture. Remember, when you're drawing it, do not draw a exactly normal curve. You're gonna draw a slightly skewed curve. Not slightly. I mean, you want the test reader to know that you're showing a skewed curve. So just do as best as you can to show a skewed shape. And then label the chi-square, degrees of freedom, and p-value. Those can all be found on your calculator. I will be doing an independent video to show you guys how to do all of those things on your calculator, but since I cannot shift my screen on my calculator, I will be wait till future videos. But I think I will post a video like that someday. Chi-squared, remember the formula. You're gonna plug the values in, or you want to get in through your calculator, you can also. Degrees of freedom, again, numbers of rows minus 1 times numbers of columns minus 1. And last but not least, states the conclusion. So everything are the same, except that this is an independence. Remember the difference between independence and homogeneity. Homogeneity is that when you have 2 samples or populations, but you only have 1 variable. But independence is you have 1 sample or 1 population, but you have 2 variables. So that's all for this video. Thank you so much for watching. I hope you learned something from it, and see you next time.